So again, what if a mixture has two liquids that have similar boiling points? We have said in the previous tutorial that we cannot use simple distillation to separate them because they will both flow together and evaporate together and go together into the collecting flask here. So what can we do, or what technique can we use in order to separate such mixtures? Well, fractional distillation is the right method. Fractional distillation is an improved method of distillation that can be used to separate mixtures with boiling point closer to each other. The extra piece of equipment used in fractional distillation compared to simple distillation is known as the fractional distillation column, and you can see that in this diagram again here. So this is the additional piece that is added on top of the simple distillation apparatus, which is this extra piece that makes the whole setup become fractional distillation. So again, the mixture that starts in a flask and the product collects, so the mixture that you want, so again, the mixture that you aim to separate, you have to place it here in the round bottom flask, and the product collects on the other side after traveling through a condenser, which is kept cooled by the action of flowing water. And of course, there is a thermometer at the top of the column, which helps you to figure out what temperature has been reached by the fractional distillation. The fractional distillation column is a very long and thin glass column, which is filled with glass beads. These glass beads act as a surface for vapor or the gas to condense on as it travels up the column. The fractional distillation method is based upon the fact that different liquids have different boiling points, so they will evaporate at different temperatures, remembering that evaporate just means to go from liquid to gas or boil. Therefore, the liquid with the lowest boiling point will evaporate first, and in a very similar way to simple distillation. They will travel up through the column and then through the condenser, where they will cool down and reform as a liquid. Therefore, the liquid will be collected in this flask down here. An important difference between the simple distillation setup shown on the left and the fractional distillation setup shown on the right is that the column is much longer in the fractional distillation model. That means any other liquids evaporating will only reach part way up the column, therefore they will cool down and turn back to the original beaker, because the long column is very warm at the bottom due to the action of heat, but will be much cooler towards the top. The glass beads also add additional surfaces for the vapors to cool on. Therefore, if the top of the distillation column has not reached the boiling point of the liquid, it will condense back down to the original flask rather than making it through the condenser to the product. This is what happens when the heat is not fully sufficient to evaporate the higher boiling point liquid, and only the liquid with the lower boiling point will reach this collection flask. Uses of fractional distillation. Fractional distillation is used in many things. First of all, we use it to separate something that is very important in our life, which is crude oil. We separate crude oil using fractional distillation technique to separate most of the things that we use in our daily life. The refinery gas, the petrol, the diesels, the fuel oil, and so many things we use in our daily life. And of course, fractional distillation is famous in the making of alcoholic drinks. So such drinks, they are made out through the technique of fractional distillation.